Welcome to the Basic Warewash Training course, AutoClaw Services e-learning online classes. In this module, we will discuss the basic dish machine plumbing. Plumbing requirements for most commercial dishwashing machines requires a minimum of 2 plumbing systems, or referred to as lines. More advanced dishwashing machines may require 3 plumbing lines. The AutoClaw machine requires a fill or supply line and a drain line. Advanced multi-stage conveyor machines require a fill line or supply line, a final rinse line, and a drain line or lines. The fill or supply line carries hot water from the primary water heater to the dishwasher. Remember, 140 to 155 degrees gives us our best results. This line is used to initially fill the machine with water to start the operation. The AutoClaw machine, this line also used to add fresh water to the machine during each cycle. This fresh water is added after the machine has completed its wash cycle and the dirty wash water has been drained out of the machine. On high temp or semi-low temp machines, this fill line is activated in various ways. If the machine has an automatic fill, it will fill to a predetermined level by simply activating a switch or by closing the door. Other machines may require the operator to manually open a fill valve. The fill or supply line consists of several shutoff valves within the line itself. The first shutoff valve is referred to as the master shutoff valve and is located at the water storage tank or the hot water heater. The second valve in the fill line is referred to as the submaster valve and is located at the dish machine. The submaster valve is needed for closing off the main fill valve as you are repairing the various components on the dish machine fill line. In legacy machines, a gate valve was used. A gate valve is open and closes the water line by turning a hand wheel clockwise or counterclockwise. Turning the hand wheel counterclockwise will open the valve. Turning clockwise closes the valve. In newer machines, a ball valve replaced the gate valve. A ball valve requires less maintenance, and it has some better options. The handle, when in line with the water line, shows that the valve is open. When the handle is across the water line, it shows that the valve is closed. The next component within the fill line is the Y strainer or inline strainer. These strainers filters debris from the water supply prior to it reaching the solenoid valve. To clean the Y strainer, turn the thumb screw counterclockwise, loosening the stirrup and the cap. Remove the cap and extract the strainer screen. To clean the inline strainer, disassemble by loosening the 2 nuts at the union connection on both sides. Remove the center canister. There will be a rubber gasket on each side of the canister. Take caution not to lose these. Remove the strainer from the canister. There will be one more rubber gasket that seals the strainer. Soak the screens in AutoClaw descale or scale clean for 1 minute. Rinse thoroughly with fresh water and replace the screens, reassemble and tighten. The strainer screen is often clogged from water deposits such as limescale or iron deposits. The next component in the fill line is the solenoid valve. The principle of the solenoid valve, regardless of the manufacturer, is the same. An electromagnetic coil lifts a plunger in the bonnet assembly, allowing water to pass under the now open rubber or metal diaphragm. The plunger and diaphragm assembly is replaceable. Repair of this component is simple provided you have the proper repair parts. Dish machines that has a final rinse solenoid valve would be located near the end of the final rinse line. This valve allows the final rinse water to flow into the final rinse arms. A variety of different companies manufacture solenoid valves. All has the same basic function and operates the same way. The next component in the fill line is the pressure regulator. The pressure reducing valve or pressure regulator is installed immediately after the solenoid valve or booster heater. The pressure regulator reduces the flow pressure of water within the fill line or final rinse line to the specified flow pressure. High final rinse pressure can cause many things. One is excessive detergent usage, excessive drying agent usage, excessive energy usage, and poor cleaning results. All dishwashing systems are required by NSF to state on the data plate of the machine the proper final rinse pressure. Generally, the proper final rinse flow pressure range is 18 to 22 psi. The final rinse pressure for AC44 or an AC66 is 18 to 22 psi. If you're working on a customer's conveyor, make sure you refer to the data plate for the final rinse pressure for that machine. The next component in the fill line is a vacuum breaker. This is a device that prevents contaminated water from back siphoning into the potable water supply. Vacuum breakers are required on commercial dish machines under ASSE 1004 or NSF 3 codes. The fill line connects to the vacuum breaker just prior to the line entering the machine. The vacuum breaker contains a float that prevents water from backing up into the potable water supply. It is important that we always inject chemicals on the downflow side of a vacuum breaker. The next component in the fill line is an air check valve. The purpose of the air check valve is to prevent the pump from surging. This surging occurs when the pump motor is sucking air through the vacuum breaker. This would not be possible if there was no vacuum breaker through which air could enter the fill line. As we just learned on the vacuum breaker, it is required that we have one. Because we must have a vacuum breaker, we must also have an air check valve to keep the pump from sucking air. The air check valve was invented by Autoclor to solve this problem. When the pump is running, a vacuum is created in the intake line, literally sucking the check valve diaphragm tight against the seat to prevent passage of air. The final rinse line. The final rinse line is found on the conveyor dish machines. The final rinse line carries hot water from the booster heater on high temp machines to the dish machine. The final rinse water does the following: rinse any remaining detergent off the dishes that have been washed, sanitize the dishes. It adds hot, fresh water to the wash tank. Therefore, it would not be wise to fill a machine with 180 plus degree water from the booster heater. The final rinse line on high temp conveyor machines is a separate line from the fill line. The reason for this is to conserve energy. The fill water to the various tanks only requires 140 to 150 degree water temperature. The second line systems that we have on dish machines is the drain lines. The drain line is the line in which water flows out of the machine. It is typically 2 inches in diameter and constructed out of PVC or copper. Some dishwashing machines may have more than one drain. In addition to the main drain, The machine also has an overflow drain. The main drain allows the wash tank and rinse tank to be carried to the sewer line or a septic tank. The overflow drain allows food soil to be drained from the wash tank by a process referred to as skimming. Food soils, oils, and fats are lighter than water. As fresh water enters the machine from the final rinse line, the water level increases. The floating food soils are then passed over the standpipe into the sewer line via the dish machine overflow drain. Prior to the main sewer line, there will be a grease trap. The grease trap collects the heavy food particles and prevents these solids from advancing to the sewer line. The grease trap must be cleaned or chemically treated with a grease digestant, such as the Autochlor Bioflow, on a regular basis. We will cover more about fill lines and drain lines in detail in our low temp and high temp dish machine modules. Learn more about basic plumbing by talking to your managers, regional manager, or vice president, or contact the training center for more information.